Welcome back to the deep dive. You sent over a bunch of articles about AI hardware,
Hmm.
and particularly, whether anybody can actually challenge NVIDIA's dominance in this space.
Yeah.
And I mean, this is a race with some pretty huge implications,
Yeah.
especially, given your interest in AI and where it's all headed.
Absolutely. And these sources are really suggesting it's a much more complex battle than just, humming up with a faster chip.
Right.
NVIDIA's grip on this market, it goes way beyond just raw processing power.
Okay, so let's start, I guess, by understanding how they became the king of AI chips in the first place, right?
Sure.
I mean, their GPUs are kind of everywhere when it comes to AI, from training these, massive models
Right.
to running huge data centers.
Yeah, their success is really deeply tied to the demands of deep learning,
Uh-huh.
where their GPUs really excel at that parallel processing, crunching through those vast data sets that these models require.
I mean, one article mentioned that they hold like a staggering 95% market share when it comes to AI
It's
chips,
huge. Yeah.
which is crazy, right?
Yeah.
And the thing that I thought was really interesting, kind of an anecdote, was about Microsoft.
Oh, right.
They're investing so heavily in developing their own AI chips,
Yeah.
but they're still buying up NVIDIA's Hopper GPUs.
Like crazy.
Like there's no tomorrow. I mean, it's like almost seems counterintuitive.
It really speaks to the challenge that anyone who's trying to compete with NVIDIA faces.
Yeah.
It's not just about building a chip that's better.
Yeah.
It's about breaking into this, ecosystem that they've very carefully cultivated for decades.
So, okay, what makes it so difficult to replace them then? I mean, is it purely a technology thing, or are there other factors at play?
Oh, it's multifaceted for sure.
Right.
You take their software ecosystem, for example, their CUDA platform.
Mhm.
It's deeply ingrained in AI development now. It's not just a programming language, it's a whole parallel computing architecture
Right.
that's been optimized for their GPUs.
Yeah.
With libraries and tools, it's practically the industry standard at this point.
I mean, it's almost like CUDA has become like the DNA of AI development now.
Yeah, it's everywhere.
To rewrite all of that code for a different type of chip
Right.
would be an immense undertaking for anyone.
It's a huge, huge amount of work, yeah.
Yeah.
And it's not even just a code.
Yeah.
Developers are just used to CUDA and its features, the way it works.
Mhm.
You switch to a new platform and you have to learn all new tools. You might have to compromise on performance.
Right.
And then you face all these compatibility issues with all the code that you've already written.
So even if, like, hypothetically, a competitor came up with a chip that was more powerful,
Mm-hmm.
it might struggle just to gain traction if the software just isn't there.
Yeah, if the ecosystem isn't there to support it.
Right.
Absolutely.
Like a chicken and the egg problem.
Yeah, exactly.
The developers won't adopt a new platform without that, robust software and the tools.
Right.
But then to build that ecosystem,
Yeah.
you need people to adopt the platform in the first
You
place.
need widespread adoption. Yeah.
So, I mean, it's a pretty formidable challenge, I would say.
Oh, yeah, for sure.
Were there any kind of specific examples from the articles that you thought really highlighted
Oh, yeah, absolutely.
the kinds of advantages that their ecosystem provides?
So one of the articles pointed to NVIDIA's TensorRT,
Okay.
which is a software development kit that's specially for optimizing those deep learning models for inference.
Okay.
So think of it like a specialized compiler
Mhm.
that fine-tunes these models to run as efficiently as possible on their GPUs.
Okay.
And this gives developers a huge performance boost and cuts down the time it takes to actually deploy those AI applications.
So, I mean, it's not just about training these big AI models.
Right.
It's about how quickly and how efficiently you can actually run them in the real world.
Exactly, exactly. Inference, as it's called, it's that process of using a trained model to make predictions on new data.
Right.
So think of it like a self-driving car using its AI model to identify pedestrians,
Yeah.
or a language translation app processing your voice in real time.
Right, right.
These are all examples of inference.
So it's like the practical application of all that training,
Yeah.
the point where AI goes from being, a theoretical concept to something that's actually impacting our daily lives.
Exactly, exactly.
Yeah.
And NVIDIA's dominance in both training and inference, that's a significant advantage.
Okay, so we've established that dethroning NVIDIA is not as simple as building a faster chip.
Right.
This software ecosystem, the need for efficient inference, it adds, these layers of complexity, right?
Sure.
But what about the chips themselves?
Yeah.
I mean, didn't one of the articles say that Amazon's Trainium chips
Oh, yeah.
were actually more cost-effective than Nvidia's for certain tasks?
That's right, yeah. So Amazon's Trainium2 chips, which are designed specifically for machine learning,
Okay.
they've shown really impressive price-performance ratios, actually exceeding NVIDIA's in certain benchmarks, particularly for those inference workloads that we were just talking about.
So there are areas where competitors are making progress,
Oh, absolutely.
but it's clearly not just a simple case of like one chip being better than the other.
No, not at all.
Right.
AI is so diverse,
Yeah.
right? There's such a wide range of applications, and each one has its own set of computational demands.
Yeah.
So, some tasks might require brute force processing power, while others might prioritize energy efficiency,
Right.
or they might need a really specialized architecture.
Yeah.
So it's not one size fits all at all.
Yeah, so it sounds like this is going to be less about finding like a single NVIDIA killer and more about this like emergence of an ecosystem
The AI chips.
of AI chips, right?
Yeah.
Where each one kind of excels in a particular area.
Yeah, that's a really astute observation. And yeah, that's a theme that really came out strongly from these sources.
Yeah.
But before we jump into, that evolving landscape,
Yeah.
there's another key aspect of NVIDIA's dominance that we need to unpack, and that's their integration within data centers.
Yeah, that's right.
Yeah.
We were talking about that, the physical infrastructure that powers all of
This
this.
physical infrastructure.
You mentioned earlier that this adds another layer of complexity.
Yeah.
So how,
So think of it like this, right? Data centers, they're designed around the specific requirements of the hardware they house. So the cooling systems, the power distribution networks, even the physical layout,
Right.
it's all carefully calibrated to accommodate like the heat that's generated by these powerful chip like NVIDIA GPUs.
So you're saying if you swap those out for a completely different kind of chip,
Yeah.
you might need to modify the entire data center.
Potentially, yeah.
Right.
It's not just a plug-and-play situation.
Right.
A new chip might have different power requirements. It might generate different levels of heat.
Yeah.
It might even need a different physical form factor.
Right.
And all of that could require these really costly and time-consuming overhauls to the existing infrastructure.
It sounds like a massive logistical challenge,
Oh, absolutely.
even for companies with the resources of like an Amazon or Google.
Even for them, yeah.
Right.
Yeah, and it's another factor that contributes to this like gradual pace of change that we see in this market.
Yeah.
Companies can't just rip and replace their entire data center infrastructure overnight.
It's like trying to renovate a skyscraper while people are still living in it.
Exactly.
You have to be so strategic and plan every step carefully
Right.
to avoid like disrupting the whole operation.
Absolutely. A great analogy.
So it's this combination of factors, the software ecosystem, the need for efficient inference, and then the data center integration.
Yeah.
That makes it such a challenge to replace Nvidia. Right?
It's a huge challenge, yeah.
Yeah. So even if, someone comes along with a chip that's, technically superior in some way,
Right.
there's all these other factors that are going to hold it back.
Absolutely.
It's not just about winning that technical battle.
Right.
It's about navigating this whole like web of logistical and economic, even cultural challenge.
Well, within the AI development community, yeah.
Yeah, exactly.
Exactly. And that's why, despite all these promising alternatives that we see emerging,
Right.
NVIDIA is probably going to stay a major force in AI hardware for the foreseeable future.
But it's not just NVIDIA and their challengers that we need to consider, right?
So-
I mean, the articles also pointed to this whole wave of new contenders entering the AI chip arena.
Yes, and that's where things start to get really interesting. It's not a two-horse race anymore. It's this diversification of the AI chip landscape.
Yeah.
You've got these established players and then all these innovative startups vying for a piece of the pie.
Okay, now this is where it gets interesting. Let's talk about these new players and how they're shaking things up. But first, a quick recap.
Yeah, okay.
I mean, we've established that NVIDIA's dominance in AI hardware, it stems not just from their powerful GPUs,
Right.
but also from that robust software ecosystem, the focus on efficient inference,
Yep.
and that deep integration within data center infrastructure. Right?
Exactly. And while some competitors are making progress, they're facing some really significant hurdles in overcoming those advantages.
Right.
But the landscape is shifting, and these new contenders, they're coming in with these innovative approaches. And that could really disrupt this seemingly unshakable status quo.
So who are these new players, and what makes them worth watching? I guess let's dive into that in part 2 of our deep dive. We were just talking about this whole new wave of contenders, right? Entering the AI chip market.
Yeah.
And I mean, it seems like it's not just about replacing Nvidia at this point, right? It's like a potential shift in like the whole paradigm of AI hardware.
That's a really important point. The articles really highlight this growing trend towards specialization. So instead of trying to find this like one chip to rule them all, companies are focusing on chips that are tailored for very specific AI tasks.
So could you give us some examples of that?
Sure.
I mean, this idea of like specialized AI chips is really intriguing.
Absolutely. So one example that really stood out to me was Groq.
Okay.
It's a startup, and they're developing what they call language processing units, or LPUs.
Okay.
And these chips are designed specifically for natural language processing tasks.
Okay.
Like the ones that power, chatbots and virtual assistants and things like that.
So instead of having like a general purpose GPU that's trying to handle everything.
Right.
These LPUs are laser focused on just one type of AI workload.
Yeah.
So what kind of advantages does that offer?
Well, one of the key advantages is efficiency.
Okay.
By optimizing the chip's architecture and instruction set for a narrow range of tasks, they can achieve these significant performance and energy efficiency gains.
Okay.
Compared to, those more general purpose chips.
Yeah, the article actually mentioned that Groq was claiming that their LPUs could be like 10 times faster.
Yeah, it's a bold claim.
And cheaper for inference than traditional GPUs. I mean, that's a pretty bold claim.
It is.
Is there anything in their technology that could back that up?
So their secret sauce is really in this unique architecture that minimizes data movement.
Okay.
So traditional chips, they spend a lot of energy just shuffling data around.
Right.
But Groq's design, it keeps the data close to the processing units.
Okay.
So it reduces latency and power consumption.
So it's kind of like designing a city.
Yeah.
Where everything you need is like within walking distance.
Yeah.
You don't need to, commute for hours to get to work or to the store or whatever.
Yeah, I like that analogy. That's a good one.
Yeah.
So this streamlined data flow, it lets them process information much faster, more efficiently, particularly for those real-time inference tasks that are so crucial for a lot of AI applications.
Okay, so Groq is just one example, though, right?
Oh, yeah, just one example.
I mean, the articles mentioned other companies taking different approaches to this specialized AI hardware.
Absolutely. We're seeing this, like, Cambrian explosion of AI chip designs.
Wow.
Each one targeting, a different niche within this broader market.
Yeah.
So some are focusing on, like, low-power edge computing, bringing AI processing to devices like smartphones and sensors.
Right.
Others are developing chips that are optimized for specific machine learning algorithms or for running, really complex simulations.
It's almost like the evolution of life on Earth.
Yeah.
You start with these single-celled organisms, and then suddenly, boom,
it explodes.
This burst of diversity with organisms specializing to fill all these different ecological niches.
I like that analogy. And just like in nature, this diversity in AI hardware, it could lead to a much more resilient and adaptable ecosystem.
Okay.
So instead of relying on this, like, single dominant species, the market could benefit from having all these different specialized chips, each one contributing to the advancement of AI in its own way.
It's fascinating to think about all the possibilities.
Yeah.
But this shift towards specialized AI chips, it raises some questions, too.
Right. It does.
I mean, wouldn't a more fragmented market create challenges for developers?
It could.
I mean, imagine having to learn a new programming language for every type of chip you want to work with.
Right. So that's a valid concern, and it's something that the industry is really actively addressing right now.
Okay.
There's a big push towards developing open standards and frameworks that can bridge these different hardware platforms.
Yeah.
So the idea is to allow developers to write code once.
Right.
Have it run on a variety of chips without having to do these like major modifications.
So instead of having like a separate set of tools for each chip, there would be like a common language that everyone could understand.
Exactly.
Right.
It's similar to how we have like standardized protocols for the internet that allow all these different devices and networks to communicate seamlessly.
Yeah, that makes sense.
So the goal is to create that same level of interoperability in the AI hardware world.
Okay.
So you can foster innovation without sacrificing accessibility.
But there's another potential challenge that comes to mind here.
Yeah, okay.
Like, if we have all these specialized AI chips, right, won't that make it harder to build these large-scale AI systems
Yeah.
that require massive computing power.
Yeah.
Like training those giant language models that everyone's talking about.
So that's an important consideration, and it's likely that in the future we'll see a combination of approaches, right?
Okay.
So for tasks that need that, like immense computational power,
Yeah.
we might still need to rely on those powerful general-purpose GPUs. Right.
Or specialized chips that are designed specifically for large-scale training.
So it's not like one type of chip is going to replace another entirely.
Right.
We're moving towards this, like, more heterogeneous computing landscape.
Yeah, exactly.
Where different types of hardware, they all coexist and kind of complement each other.
Precisely. The key is going to be figuring out how to efficiently connect and coordinate all these different chips.
Right.
Creating this, like, symphony of processing power.
Yeah.
Where each instrument plays its part.
I like that.
Harmoniously.
Yeah.
Yeah.
Now, that's an analogy I can get behind. But this brings us back to those big tech companies we were discussing earlier, right?
Yeah.
Amazon, Google, Microsoft.
Right.
They're all investing heavily in their own AI chips, but they're also still relying heavily on Nvidia.
Yeah.
So how does this trend towards specialized hardware impact their strategies?
That's a great question. And that's where this, like, strategic landscape gets even more interesting,
These companies are essentially hedging their bets.
Okay.
So they're developing their own specialized chips for specific tasks.
Right.
Where they see a clear advantage.
Okay.
But they're also continuing to use NVIDIA's GPUs for, more general purpose AI workloads.
So it's like having a toolbox with both specialized tools for specific jobs.
Right.
And then your, trusty old hammer that can handle most everyday tasks.
Exactly. They're not putting all their eggs in one basket.
Right.
They're exploring these different approaches. They're learning from their own chip development efforts. And they're keeping a close eye on what these startups and other chip makers are doing.
So it's a bit of a balancing act for them.
Yeah.
They want to reduce their dependence on NVIDIA.
Yeah.
But they also don't want to miss out on the benefits of that mature ecosystem.
Right. Exactly.
And that proven hardware.
And this cautious approach, it makes sense.
Yeah.
Developing and deploying new hardware at scale,
Yeah.
It's incredibly expensive and it's risky. You can't afford to get it wrong.
It's like navigating a minefield, right?
Yeah.
One wrong step could have, disastrous consequences.
For their AI ambitions.
For their bottom line.
Exactly. And that's why, even though we're seeing all this exciting innovation in the AI chip space, it's unlikely that NVIDIA is going to be dethroned overnight.
Right.
They still have this commanding lead.
Right.
And their competitors, they're playing a long game.
But that doesn't mean the game is over, though, right?
No, not at all.
This emergence of specialized AI chips.
Yeah.
It's changing the rules of the game.
Absolutely.
It's creating new opportunities for disruption and innovation.
It's a whole new ballgame, yeah.
So what started as a question of, can anyone replace NVIDIA?
Right.
Has really evolved into this much broader discussion about the future of AI hardware itself.
Exactly.
I mean, we're seeing this fundamental shift in how we even think about processing power.
Yeah.
We're moving away from this idea of one-size-fits-all chips.
Right.
And moving towards this, more specialized
and adaptable
ecosystem.
Yeah, absolutely.
Yeah, and this shift has, some pretty profound implications.
Oh, yeah.
Not just for the tech industry, but for, the future of AI as a whole.
Absolutely. So the availability of, affordable and efficient and specialized AI hardware, that's going to unlock new possibilities in every field you can think of, from healthcare and transportation to manufacturing and entertainment.
Yeah.
It's really going to change everything.
It's exciting to think about how this is all going to unfold.
Yeah.
But as we've been discussing, this technological evolution, it raises all these important questions too, right?
For sure.
About the software ecosystem, the challenges of integrating this into data centers.
Absolutely.
The strategic motivations of all the major players.
Right. And let's not forget about the impact on the developer community.
Yeah, that's right.
Will this more fragmented hardware landscape lead to greater choice and innovation?
Yeah.
Or will it create, fragmentation and compatibility issues that hold back progress?
It's a great question.
Yeah.
And it's one I think we should explore further.
Definitely.
As we delve into, the strategic implications of this AI ship race and the final part of our deep dive. Okay, so we've talked about NVIDIA's dominance, all the challenges coming up, and this whole trend towards specialized AI chips. But, stepping back, what does all this actually mean for, like, you? I mean, you're interested in AI and the impact it's having, and this hardware race, this could really shape that future in a big way.
Oh, for sure. I mean, beyond all the technical details, we're seeing a real power shift happening in the tech world. AI is becoming like the defining technology, and whoever controls the hardware that runs it, well, they hold a lot of influence and a lot of potential profit.
So it's not just about, like, market share at this point.
Right.
It's about shaping, like, the future of AI itself.
Exactly. The outcome of this race, it's going to determine who controls the costs of AI development, who sets the standards for both hardware and software,
Right.
and ultimately who has the biggest say in how AI is used and how it evolves.
It makes you realize, like, how high the stakes really are.
Yeah.
I mean, if one company gains too much control, could that stifle innovation? Or even, like, limit AI's potential to benefit everyone?
It's a valid concern, and it highlights this tension that exists between, specialization
Right.
and the need for this, like, robust and accessible ecosystem.
Yeah.
Will a fragmented market with all these specialized chips, will that lead to faster progress? Will we see more tailored solutions?
Right.
Or will it just create this chaotic landscape where developers are constantly struggling with compatibility issues?
It makes me think back to, like, the early days of personal computers when you
Right.
had all these different, like, incompatible systems.
Yeah.
It made it really hard for software to take off. So could we see something similar with AI if everyone's just building their own little walled garden?
It's definitely a risk, and that's why this push for open standards and interoperability is so crucial.
Yeah.
We need frameworks that let developers write code once and have it run efficiently on a whole bunch of different AI chips.
Yeah.
Otherwise, we risk slowing down progress and limiting the accessibility of AI technology.
So it sounds like finding that balance, between specialization and standardization.
Yeah,
That's going to be key
it is.
to unlocking AI's full potential.
Exactly. And it's not just a technical challenge either.
Right.
It involves collaboration across the whole industry, from the chip manufacturers to the software developers and even policymakers who need to step in and ensure a level playing field
Right.
and prevent any anti-competitive practices.
That's a good point. It really highlights how this goes way beyond just building better chips.
Yeah.
It's about fostering this whole ecosystem, right? So that supports innovation, accessibility, and responsible development
Absolutely.
of AI.
Yeah.
But for companies like Amazon and Google and Microsoft, who are putting so much money into developing their own chips,
Yeah. Yeah.
isn't there a conflict there? I mean,
Yeah.
they want to be the leaders, right?
Right.
They don't necessarily want to make everything open for everyone else.
That's the dilemma they face, right?
Yeah.
They want to control these key parts of the AI supply chain,
Yeah.
but they also have to consider the broader market forces at play.
Right.
If they make their platforms too closed off,
Yeah.
they risk alienating developers
Right.
and falling behind in the long run.
It reminds me of that tension that exists between, like, open source software and proprietary platforms.
Yeah,
Sometimes being too controlling can really backfire.
it can.
Look at what happened to all those companies that tried to compete with Android
Right.
by keeping their mobile operating systems totally locked down.
It didn't work out too well for them.
Yeah.
It's a good analogy because in this fast-paced tech world,
Yeah.
collaboration and openness, they often win out over attempts to create these closed ecosystems.
Right.
The companies that can find that balance, between protecting their own interests
Yeah.
and fostering this vibrant and interoperable AI landscape.
Yeah.
Those are the ones that are going to thrive in the long term.
So as we wrap up this deep dive, I mean, what's the key takeaway for you? Like, you listening out there, you've seen how complex this world is, but what's the one thing you should really be thinking about?
For me, it's this. The decisions that are being made today about AI chips, they're going to have ripple effects for years to come. They're going to shape the future of AI itself.
Right.
It's not just about who builds the fastest processor.
Right.
It's about who creates the most supportive and adaptable ecosystem for AI to really flourish.
So it's not just about the chips themselves.
No.
It's about the bigger picture.
Exactly. Stay curious. Keep learning about these developments and ask yourself, how might these choices impact the future you want to see?
That's a great note to end on.
Yeah.
It's been a fascinating exploration.
It has.
I think we covered a lot of ground.
We did.
We started by asking, if anyone can dethrone Nvidia, and we ended up with a much broader understanding of all these forces that are shaping the future of AI hardware.
And as we've seen, it's a rapidly evolving landscape, you know? What's cutting edge today might be obsolete tomorrow.
Right.
The only constant is change. And the people who can adapt, who can embrace the challenges,
Yeah.
they'll be the ones shaping the future of AI.
That's a wrap on this deep dive into the world of AI hardware. Thanks for joining us, and as always, keep exploring and keep those questions coming.